Hi class, let's take a look at problem 10. Now on problem 10, we have a piecewise defined function and technically we have three conditions. Let me start with the easiest one to do, which is technically the middle one that is just a coordinate point at 3, 7. So technically at 3, 7, we're gonna have a dot here. And for the first one, it's gonna be the graph of x if x is less than 3. So at 3, you're gonna have 3, 3, but with an open circle. Your function is gonna be going in this direction. The last one, it's a parabola. So we're gonna be trying to graph a parabola. So it's gonna have a little bit of a curvature at 3, and your coordinate point is gonna be 3, 9. So at 3, we're at technically 9 with an open circle. And I'm just gonna say that this is your parabola going in this direction. Let me try to fix the angle or the curvature. There we go. Okay, that's actually it for the graph. This will be the graph of technically f of x. Now let's take a look at the limits. Problem A says find the limit as x approaches 3 from the positive side. So from the positive side, as x gets very, very close to 3, our function is going to be approaching 9. So this is equal to the values of 9. The next portion is asking for the limit as x approaches 3 from the negatives. From the negative side, as x approaches 3, our y value is going to be 3. So this is equal to 3. For the next portion, it's going to be as x approaches 3. Now, notice that, well, our function is approaching two different values. On the positive is approaching 9. On the negative is approaching 3. So we would say on this one that it does not exist. And then we can just say, since the limit as x approaches 3 from the positive is equal to 9, and the limit as x approaches 3 from the negative is equal to 3. Most of these, I'll be asking for some sort of a justification. The software is just going to be asking for does not exist or D and E for the limit. The last portion, it's going to be f of 3. Now, our function is defined at 3, and this is going to be equal to the values of 7. I have the graph here, so we can take a look at the graph with a scale. You can actually see that at the values of 3, we do have a dot at 3, 7. Then there's technically a break in between the two pieces of the function. Okay, for the last portion, the question is asking if the function is continuous at x is equal to 3. And in this case, we can say, no, it's not continuous. It has a break. And basically, for the function to be continuous, you have to have the limits in the function value agreeing at the same point. On this one, I'll just say, no, the function is not continuous at x is equal to 3. Since technically f of 3 is equal to 7, and the limit as x approaches 3 of f of x does not exist. In a next section, we're going to be talking about the requirements for a function to be continuous. and these will be the requirements. In order for your function to be continuous, your function value, in this case 3 is the one that we're talking about, and the limit as it approaches from the left and the right has to be equal. In this case, we could have also said, since it's not asking for the proper definition, that there is a break in the graph at x is equal to 3. That's actually it for this problem.